Now we're ready to talk about the idea of continuity, of a function being continuous. So we can say f of x is continuous at x equals c if three conditions hold. Condition number one is that the function evaluated at that point simply must exist. Second, what must be true is that the limit of the function at that point must exist. And finally, it must be true that when we take the limit of the function at that point, it equals the value of the function at that point. Those three conditions must be true in order for the function to be continuous. So for example, if what you have is simply a hole, a missing piece in the function, that's a discontinuity because f of c does not exist. Similarly, if you had at c a vertical asymptote, that would also be an example of the function simply not existing. Okay, it may be that the function exists, but the limit doesn't exist. So for example, we could have a jump discontinuity. So the function exists. We can actually plug in and get a value at f of c, but here the limit as x approaches c of f of x is undefined. That doesn't exist. So this is an example of a function that fails the second condition. And finally, a function that fails the third condition, we could have a removable discontinuity and then a separate value at that point. So here we can plug in c. The function definitely exists. It's that one point floating above. We can also take the limit, and of course the limit approaches the hole in the function. But the trouble is that when we take the limit, it doesn't equal the value that we get when we actually plug in. So this is an example of a function that fails the third condition. F of c does not equal the limit as x approaches c of f of x. So a function must satisfy all three of these conditions in order to be considered continuous at a point.